Stanford University.
All right, guys. Welcome back again to CS193P Lecture 14. Today we're going to be talking about multi-touch events and gestures. I'm going to steal that from you. Obviously, we've got another guest lecturer today. Jason Beaver works with me on UIKit at Apple. He's going to be talking about multi-touch events and gestures. He was one of the first people actually working on the UI Touch and UI Event APIs at Apple, so you can thank him for all the cool stuff that we've been doing since then. So a couple of announcements first. We've got Presence 4 is due next Wednesday. That's paparazzi for you. Yeah, that's what I meant. I'm reading. Yeah. Yeah, and the final project, obviously, proposals were due yesterday, so a little bit late notice, but we've been saying it for a while, so hopefully everyone got theirs in. I know we got a big mess of them at 11, 12, 1, 2, 3, 4. So good work with that. If you didn't get them in soon, just get them to us, and we'll get back to you on all of that. So that's really all I have. I'm going to turn it over to Jason for touch events and multi-touch.
Thanks. All right, so let's get started here. So before the iPhone came out, I mean, there were lots of mobile devices, and the way you interacted with them was scroll wheels and buttons and things like that. A few had touch screens, but it was using the stylus and things like that. But most of the interaction was rather indirect. If you want to scroll something, there was some sort of scroll wheel. If you wanted to click on a link, you had to somehow navigate via buttons or whatnot to a link and find some button to select it. The touch interface really sort of changed all that. It let you directly interact with things. If you look at the video here, you can really naturally scroll around, zoom in and out on things, click on links without really having to learn anything. I mean, I can hand this to my 2-year-old and she can kind of run around and figure out how to navigate. But so this list really gives your users the ability to interact with stuff on the screen a lot more like they do with a mouse on the desktop, where they can kind of directly interact with content. But fingers really aren't like mice. They're kind of fat and pudgy, at least mine are. So when you touch on the screen, it's not a very precise touch point. When you touch on the screen, it's actually sort of an elliptical contact patch that the driver sees. And as a developer, though, you really just kind of want to know about the points that the user clicked on. And it turns out it actually isn't just the centroid of this. When we did a lot of studies having users touch on things on the screen, they tended to think they were touching at things right at the tip of their finger, but the pad of their finger was quite a bit below where they touch. And even that was dependent on sort of the shape of that ellipsoid. So the driver in the iPhone actually analyzes all that information as well as the orientation of the screen and computes sort of a single touch point where the user most likely thought they were trying to click. And that's what we pass on to the applications. So we're going to talk about a few different things today. So we're going to talk about a full touch sequence, what happens as the user's finger comes down, moves around on the screen, and then lifts. How the touch is represented to your application and delivered to your application. And talk about single touch sequences, multi-touch sequences if multiple fingers are on the screen, and what happens if those fingers are actually in different views or different objects on the screen. We'll talk a little bit about how the touches are routed within the application to the views you're interested in. And finally, if all you really want to do is associate some action with something like a tap on the screen, the UI control class actually lets you sort of forgo knowledge of the intricacies of the touch handling and just sort of immediately assign that binding. So we'll talk about that a little. So let's start with what a touch sequence is. Starts when the finger contacts the screen, obviously. We'll continue to update touch location as the finger moves around on the screen, and then you'll be told when it lifts. So how's that represented in the application? There's a class called UI Touch that represents a finger on the screen. It has several different properties: a timestamp that represents the last time the touch was modified in some way, a phase, which indicates what the touch is doing right now. Did it just begin? Is it moving? Is it stationary? If it just ended, things like that. And a tap count. Tap count's kind of special. If the touch is relatively stationary and relatively short duration, such that it sort of looks like a tap, we'll increment this tap count, and subsequent touches in the same general area within a short enough window of time will actually increment that touch. Even though it's a new touch instance, we'll pull data from those previous touches and up this tap count so you can look for double taps pretty easily. There are a couple of properties on the touch that associate it with a window in your application and further for a view within that window. When the touch first comes down, UIKit figures out which window on the screen should receive that touch. In almost all cases, there's just one that's full screen. And then the window further figures out which view in there should receive the touch. And you have quite a bit of control over that, and we'll talk about that when we get to touch routing. And finally, there are a couple of methods on the touch to find out where the touch is. There's location in view and previous location in view. If the touch is moving, you can find out where it was. You can use this for simple velocity calculations and things like that. Notice there is a view parameter. You don't have to find out where it is in the view that it's bound to right above. You can actually pass any view in the system, so you can find out where it is in its super view or even in the window just by passing in the window there. UI touches are delivered within a container class called a UI event. This has a single property called timestamp, whenever the last time the event was modified in some way. And there's three methods to get a hold of the touches that are in there. You can ask for all of the touches, and these are every touch that is tracking somewhere inside your application. Touches for window, obviously gives you the ones in your window, and touches for view gives you the ones that are in a particular view. And these are the ones that are specifically bound to that view or window. So graphically, we have an event. It contains some set of touches for all the fingers that are on the screen right now. Those are bound to some set of windows and further to some set of views within those windows. If we ask for all the touches, we'll get back a set with everything. If we ask for touches for window, for window A or window B, we'll get some set for the appropriate touches there. And then finally, touches for view, we can ask for the various views, and we'll get back sets containing just the touches that are bound to those views. There we go. Okay, so let's talk about how your view is actually notified about these touches.
Actually, how does who decides which event object each touch object or touch instance goes to?
So the question is, who decides which event object, which touch is associated with? There's only one sort of event at any given time, and it has all of the touches that are associated, that are tracking on the screen right now. And that's the event that's delivered. I don't know if you guys have talked about send event at all. There are methods on UI application and UI window just called send event, and they take a UI event. So when anything changes in the system, related to touch tracking, for example, those methods, the application's send event gets called with a UI event. It just has a set of touches. It figures out what windows those touches are bound to and calls send event on those windows. And then from there, we analyze the touches and figure out sort of what's changed. Did a touch just move? We better tell the view the touch moved. So to receive touches, you need to be a subclass of UI responder. UI responder has 4 methods defined on it for touch handling. Touches began with event. Notice it takes a set of touches. These aren't ordered in any way, which is why it's a set. And this will be the set of touches that just began. Touches moved has a similar signature. This is also just the touches that have moved. If there are multiple fingers in the view and only some move, you'll only see those in the set. Touches ended, similarly, the ones that have ended will be in that set. There may still be other fingers tracking in the view you need to be concerned with. And finally, touches canceled. There are several events in the system that can cause touches to get canceled. Things like an alert popping up or an incoming phone call, things like that will actually cancel out all the touches, and the views are expected to clean up after themselves and sort of put state back in something that makes sense for whatever they're doing with the touches. UI responder is a direct subclass of NSObject. And we've got a few direct subclasses of UI responder in the system. Application and view controller, the ones on the outer edge there, can handle touches, though that's typically a little rare. UI View, though, is the primary one, and most of the classes in UIKit are actually subclasses of UI View, which means they can all handle touches. So for a single touch sequence, imagine some view filling the screen here. Finger comes down on the screen. We'll figure out which window and which view that touch is associated with. And we'll send that view a touches began with event. And the set of touches will, in this case, contain just a single touch. One thing to note here, we've showing sort of a simulated address here. So that's the pointer to this touch. In this case, it's 1, 2, 3. For the entire time a finger is tracking on the screen, it's represented by a single UI touch instance. And you can actually hang on to that and even associate data with it if you want to associate data with that finger as it's moving around on the screen. The phases began because obviously this touch just began, and there's some location that represents where the touch currently is. As it moves, that view will receive a series of touches moved with event calls. It's the exact same touch instance. The phase is now moved, obviously, and the location will be updated to reflect where it is. So you'll just get a series of those pretty much as fast as the driver is processing those. When the finger finally lifts, you'll get a touch as ended, again the same touch instance, but it's in the ended phase, and you'll be told where it was when it lifted. For cancellation, it's pretty similar. The finger will come down, you'll get a began, you'll get a series of moves in the same way, but let's say a call comes in at this point. Instead of the end, you'll be sent touches canceled. So you'll get one of those two end calls, but not both.
How long does a UI touch live for?
It lives as long as the finger's on the screen.
And then it's lifted when the phase changes to ended or lifted, then the thing gets
at the end of the run loop, it'll go away.
Okay.
Yeah, it's auto, I think auto released at this point, and so it's sent via send event, which means it's sent to touches ended. You can certainly interact with it there, but it'll go away at the end of that. You shouldn't hang on to it beyond that time. All right, so we're going to do a simple demo here. This is just a simple full screen app with a little image view in the middle, and we're going to start with just handling a single touch, and we want to be able to sort of move that photo around on the screen. So the video will look sort of like that.
I want to say one thing about that last point, actually. The touch instance will go away as soon as the finger lifts, like Jason said, but if another finger comes down right away, the odds are reasonably good that it's actually going to end up being at the same instance. Like the address of the instance for the next one will be the same because the memory allocator will try and reuse recently deallocated memory, and since it needs another instance of UI touch, which will be the same size as the one it just deallocated, it'll probably get that same address back. So it's especially bad to hang on to the address of the touch past touches ended because you might not even notice it. It might not crash. It might just start looking at the next touch that just came down afterwards.
Right. Okay. So I have a simple little project here. There's really nothing in it so far. There's an application delegate which gets the main view controller and puts its view in the window. There's the view controller, which doesn't do much of anything except set a background color to white. And there's this touch image view, which is nothing more than a subclass of UI image view that will handle touches, so we can move it around. At this point, there's actually nothing in it. There's just a simple init with frame and a dealloc. So we want to start actually by creating that image view. So we'll load an image. We have an image that's in our application bundle already called Flowing Rock. Can everybody see that okay? This is just a little bit of math to scale the image down to some size, 200 pixels wide, and keep it at the right aspect ratio, and then create an image view with that frame. We'll go ahead and assign the image view the image, and set the center point to, in this case, just be the center of the parent view. And then we'll add this view in as a sub-view of our view controller's view. And then finally release it. touch image view is that image view that we saw in the middle that was moving around. It had that sort of flowing rocks picture in it. It's just a subclass of UI image view. Let's move on here. So in our touch image view, we need a couple of instance variables. We're not going to get into sort of the specifics of how some of this work. The sample, I think, will be made available, and you can look at some of the transform handling when we start to do multiple fingers. But for simplicity, so we don't have to rewrite it when we move to the multi-touch version of this app, we're going to do this the same way now. So there's a transform, an affine transform that just basically represents how the image is scaled and rotated and moved from the default location. And then there's a set of begin points so that we know we can compute, given where the fingers are now and where they started, what that transform is. So we want to fill in that original transform with just the identity transform so that it stays where it is when we first create it, and create a dictionary of the original touch points. And then I'm going to do one more thing here, which is set user interaction enabled. I don't know if you guys have talked about this, but there's a flag on UI view that says whether it can receive touches or not. UI image view, by default, has that turned off because you typically don't need to interact with an image in some way. So we want to turn that back on in our subclass so that this view can receive touches. So we'll start with defining the touches began. And in here, all we're going to do is just cache all these begin points. And these, again, some private methods we're not going to get into. In our moved, we're going to compute this incremental transform, which is basically, again, relative to the starting location of all these touches. And then we're just going to concatenate that with our current transform and set that to be the view's transform. So that'll take care of the moving and whatnot. And then finally, in touches ended, all we need to do is update that original transform so that subsequent touch sequences will treat that as the baseline. So it won't snap back to where it was. It'll continue from there. And then we want to throw away those touches that we cached so that we can recache them next time. And finally, and very importantly, we need to handle touches canceled so that we can clean up after ourselves. And in this case, there's several things you can do. In some cases, you might want to reset things back to the way they were at the beginning of the touch sequence. In this case, we're sort of moving an image around. We probably just want to drop it right where it is. So we want to do the exact same thing touches ended is doing. So in this case, we can just call touches ended. All right, let's run this and see how it looks. So we have the UI image view that's popped up in the middle, and if I click on it, I can sort of drag it around. If I drop it, I can pick it up again from somewhere else, and notice it sort of tracks from wherever my finger is. It's not centered on the finger or anything like that. It's all just in relative position. Okay. Any questions on that? Okay. All right, so let's now talk about what happens if there are multiple fingers on the screen. By default, any individual UI view will only be told about the first touch that contacts it. Any subsequent touches will just be sort of dropped by the system. The sort of assumption is that it's complex to deal with multiple touches, and that unless you explicitly tell the system you know how to do that, we don't want to potentially cause problems in the application by delivering a bunch of touches that it can't handle. So if you can handle multiple touches in your view, all you need to do to enable it is set the multiple touch enabled property on the view to yes. And then, now if you have a view here and we've got a couple of fingers, because this is the way everybody uses iPhones. First finger comes down on the screen, and we'll again find the appropriate window in view. We'll send that view a touches began, and we've got here, in this case, touch instance 1, 2, 3. And as it moves, we'll send touches moved, same instance. So far, this is exactly like the single touch case. When a second touch comes down, the view is going to receive a second touches began with event message. In this case, there's a new touch, ABC, and it's in the began phase. And notice that other touch, sort of grayed out right now, it's actually not delivered as part of this message, and it's in the stationary phase. If you were to ask the event for all the touches for this view, you'd find that touch, and if you asked it for its phase, you'd see it's not moving. If both move at the same time, the view will receive a single touches moved message. The set will contain both touches. They'll both be in the move phase, and they'll both have updated locations. If just one moves, the view will still receive touches moved, but the set will just contain the one that's moving again. The other one's stationary. And then when they lift, you'll get a touches ended. The set in this case contains both, but if they lifted one at a time, you'd receive two calls to touches ended, each with a set containing just the one that ended at that time. So let's modify this demo now so that our touch image view can process multiple touches. And what we want to do is compute a transform so that we can do things like scale and rotate and also sort of drag around that photo. Okay. So the first thing we need to do is go to our touch image view and tell it that it can handle multiple touches. So we're going to set the multiple touch enabled property to yes. And then now in our touches began, we used to just cache the begin points, and that's all we needed to do there. But now the set of touches are actually changing there. So we need to do a little bit more work to adjust that transform. So the first thing we're going to do is ask the event for all of the touches for our view. We're going to make a copy of that. And then we're going to subtract out the set of touches that just began by using this minus set method on in a set, or in a mutable set. And this gives us the set of touches that were in contact with this view prior to this touches began. And if we actually have touches that were in contact, we want to update the original transform, which is exactly sort of what we needed to do in touches ended. And then we're just going to recache the begin point. So it's going to effectively look like we started over with this new set of touches. In touches ended, we need to do a very similar thing because not all of them may end, obviously. So we'll figure out the remaining touches by getting the touches for view and subtracting off the ones that have ended. This will leave the ones that are still present on there. We'll cache the begin points for those. And that's really all we need to do. So now if I don't have a lot of flexibility in the simulator to move these around like I do on the phone. They basically will stay around the center point if I want to do rotations. But I can click and you can see I can rotate and scale. If I can also still translate, but I can't do both at the same time in the simulator, although on the device obviously you can. All right, so that is the second demo. Any questions on that?
Could you explain what transform with touches does in your message?
Let's see. We probably have a little time to jump into that. The question is, can I explain what the transform for touches does? Yeah, let me bring that up. So there are several methods there. There's a method to cache the begin points. Basically, that just runs through and gets the touch begin point out and sticks it in the CF dictionary so that we can use that for subsequent calculations. And there's a corresponding remove touches from cache method. The interesting bit of work is actually in this incremental transform with touches. This takes the baseline transform, if you will, and then given the relative positions of the current fingers and where they started, computes what that new transform is. And basically, it's just solving a series of equations, which I'm not going to be able to describe. Somebody should put some comments in here explaining what these do. But this is, I think you can find this in most of the graphics textbook, how to do this. There's actually a little comment here about solving this series of matrix equations. So that's all it does, is just computes that new transform. And then we can just directly apply that. So and this is actually available as a a sample on developer.apple.com that anyone can download. You can just drop this little chunk of work. And yeah, it'll be on the class thing too, but if you wanted to get it early, it's up there. So. All right, any questions? All right, so now let's talk about what happens if those touches are in multiple views. So in this case, we have a real simple app with just two big views. And really, this is going to work exactly like the single touch case, but for each of these two views in isolation. The left view will receive a touch as began, be told about its touch, and as it moves around, it'll receive touch as moved. Another finger contacts the second view will receive a touch as began. The first view won't be told anything because the only touches that are associated with that view aren't doing anything. If both move at the same time, each view will receive a separate touch as moved with event, and the set of touches will only contain the touch that's associated with that. In fact, if you were to ask the event for the touches associated with that view, you just find the one associated with either view. If you were to ask it for the touches for that window, you'd find out about both, and you could actually even find out that that other touch was in another view, though it's pretty rare to look at that information. Again, this one just moved, that one view receives a touch as moved. And they lift here, and both views will receive a separate touch as ended with event message. Yeah?
What happens when you put your finger in one view and then you move it to another view?
So the question is, what happens if you put your finger in one view and move it to another view? Once we have made that binding to a view, that view will receive all updates to that touch from that point forward. So even if you move into another view, the first view will be told about it. The coordinates you will receive will actually be outside that view's bounds. So it's where it would be if the view extended that far. So even that can include even negative bounds if something moves off to the upper left part of a view. So it can be a little complex sometimes to handle touches in multiple views simultaneously. It may not always be valid to do that. So to provide sort of a high-level control. I'm sorry, there's another question.
Yeah, back to the previous question.
Sure.
Is there a way to assign a specific touch or a specific view to a touch?
Yeah, we're going to get to that when we talk about touch routing. But yeah, you have full control over how touches get bound, to some degree, I should say. Full control. So to give you some high-level control of how touches get tracked by multiple views, there's a property called exclusive touch. Now, if a finger comes down on a view that's marked with this true, and this is false by default, but if the finger comes down on a view that's marked by this as true, that view will only be told about the touch if there are no other fingers tracking in other views within that window. And conversely, if you put your finger down in a view that's marked no, not exclusive touch, that view will only be told about it if there are not fingers somewhere else in the window that are tracking in an exclusive touch view. Little confusing, but the simple way to think about it is if you mark a view as exclusive touch and it is ever told about a touch, you're guaranteed it's the only view in the window that's processing touches at that point. So if you have, for example, two buttons in your interface and both of them do incompatible things, it would not be valid for the user to click both of them at the same time. You can just mark them exclusive, and we guarantee that the user can't click on both at the same time. However, if you're building something like a game or something like that, where you want to be able to move and fire at the same time, you probably don't want to set that to true. So we're going to extend our demo one time further here. We're going to add several image views, and we want to be able to interact with all of them at the same time, or show how we can control or limit the user to only interacting with one at a time. So in this case, I did this video with a simulator, and the simulator doesn't really give you the ability to put more than two fingers down, so I can't really do a demo of what you can really do with this, but you can actually pick up multiple with two fingers each and rotate and scale multiple ones at a time. But you have to have a real device to do that. So let's see what we have to do to interact with this. All right, so we're going to go to the view controller. We're creating one image view here with that little block of text, and we'll just do the simple thing here and just duplicate that block of text a couple of times. Obviously not ideal or very maintainable, but so we'll just load two different images, a clownfish image and a stones image, and we'll just position them at different starting points. So with just this change, if we run the demo, we'll see multiple images. I can still interact with any one of them. I can still rotate and scale any one of them. Or I can pick two up and move them around sort of separately. And like I said, if we're on a real device, you could even rotate and scale multiple at the same time. But suppose you didn't want to actually let the user interact with all of these at the same time. To fix that, all you need to do is go over to the touch image view and just specify that it's an exclusive touch view. And this will prevent the system from delivering touches to more than one of these at the same time. So now I can still interact. I can still put multiple fingers in one view. This doesn't stop multi-touch. It just stops multiple views. Now if I put touches in these two, only one of them is going to get the touch. The order is, if they're exactly the same time, the order is really not defined, but generally there's some tiny window between them, so it's not an issue. Let's see. There's one other little thing that I have here we'll throw in to the demo, which is, if you look at this, you can have views that are behind other ones, and there's really no way to reorder those. But suppose you wanted to have ability to maybe double-click on one of these and have it pop to the front. All we need to do is, in our touches ended, just go through the touches that are touching there, check to see if the tap count's greater than or equal to 2, and then just call the method on the super view to bring that sub view to the front. And if we run this now, so I can scale this, but if I double click on it, it'll bring to the front. All right, any questions? Okay. Okay, now we're going to get to the point that the question you had about touch routing. How do you control what view gets bound to these touches? So let's first talk a little bit about the responder chain and how touches get delivered to a particular view. Once we have that binding of a view and a window for a touch, and we send that message, touches began or whatnot, to a view, that view may actually not provide an implementation for that. And if it doesn't, the responder chain takes care of trying to find some other object that knows how to handle that. So it'll first try the view's view controller. Remember, the view controller is a subclass of responder, so it can handle touches. If it doesn't provide an implementation or handle those touches, we'll go up the super view list. So basically, we'll start with that view super view, we'll check its view controller, and we'll just keep working our way up the view hierarchy, trying to find some view that can process these touches. Eventually, we'll run out of views and we'll hit the window. So the window gets a shot at handling the touches. And if the window doesn't do it, finally the application gets to do it. This is pretty rare. I don't know that I've ever seen a real app that tries to do it this way. But for consistency's sake, it does actually flow all the way up the responder chain to the application. In most cases, only the root view in the window has a view controller associated with it. So this is more typical of what the responder chain looks like. So a touch comes down on the screen. The first thing we do is we figure out what window. You don't have actually a lot of control of that. Windows binding to a window is something the system takes care of for you. But inside the window, you actually have quite a bit of control of where that touch gets routed. So in this case, the window is going to look through all of its subviews. Here we just have a single one. And it's going to call a method called hitTestWithEvent on that view. That's going to check a few different properties. It's first going to check user interaction enabled. That's the thing we had to set on the image view to allow it to receive touches. If that's no, we skip that view, which means we skip all of its descendants. We next check to see if the view is hidden. Views can still be in the view hierarchy, but not on screen just by setting the flag to hidden. We don't want to route touches to those views, so if it's hidden, we'll skip it. Also, if the alpha is sufficiently transparent, if you're down to just a few % transparency, so it's virtually gone, we won't route touches to it because the user really can't see it. And finally, we'll call a method called pointInside with event. This just determines whether the finger is inside or outside of the view. So in this case, that view will return that it's enabled, it's not hidden, and the point is inside. So it'll do the same thing. It'll start calling hitTestWithEvent on all of its children. And this is the default behavior you just get by UI view. And so with this, we'll descend all the way down the view hierarchy until we find the deepest thing that meets all of these criteria. So if there's a button inside a view, inside a table cell, inside a table, whatever, the button's the thing that ends up getting the hit testing or getting bound to the touch. But if you want to change that for some reason, even though you have views that are in your app that can process touches in a parent super view, you can override hitTestWithEvent and control that. If you want to return a different view, you can do that, even a view that doesn't meet these criteria. So once we found that deepest view, we will bind the window and view properties and the touch to that, and those are fixed from that point forward. So let's talk a little bit about UI control. I mentioned earlier that if all you want to do is associate some action with some event like the user tapping on something, you don't have to handle touches directly to do that. UI control provides a way to simplify that. There are a set of events that UI control provides. If you touch down on a control, that triggers an event that you can associate an action with. Or if you touch down repeat, which is basically multiple taps on a control, you'll get this touch down repeat event, and you can just set that to fire off some method on some object you own. If the touch moves around either inside or outside of the control, we'll send two different events for those. And as we cross the boundary, either entering or exiting the control, there are events associated with that as well. And then finally, when the touch lifts either inside or outside of the control, there's associated actions or events there. So the typical thing is like you have a button. When the user taps on it, you want to do something. All you have to do is set up an action associated with the touch up inside control event, and your action will get called when they tap on the button. If they do something like press and hold on the button and move out and lift, you won't see anything. If you press and hold and move out and in, back and forth, but finally lift inside, you will see it. And you don't really care about what's happening with the touch in the middle. There's one final one, which is cancel. This is really similar to the touch is canceled thing. If a touch does get canceled, you can find out about it. So let's look at how we associate those actions. There's a method on control called add target action for control events, so you can actually specify multiple control events for a single action. The target is the object you want to receive the notification, and the action is just some method selector. I assume you guys have talked about all that kind of stuff, right? The action can actually have three different signatures. It can be a method that takes no arguments. It can be a method that takes a single argument, which is the control that triggered the event, so button or whatever. Finally, it can take two arguments, and the first one's obviously the control that generated the event, and then finally the event itself, and that allows you to get in and look at the touches if you need to. So if you subclass UI control and want to actually look at the touches that are being processed, there's a set of methods to do that. These are somewhat analogous to the touch handling methods. There's begin tracking with touch with event, continue tracking with touch with event, end tracking with touch with event, and finally cancel tracking with event. The main difference here is that there's a touch argument directly passed in because controls don't know how to deal with multiple touches. They're all single touch objects. So you don't have to worry about it being a set of touches. It's just the one touch that's interacting with the control. So we've got a little demo here where we've got a single control, which is a button down at the bottom. And I've associated actions with every one of those events. And when the event fires, you'll see the text associated with that sort of darken for a second and then fade out. So you can sort of see the stream. So let's look at this. Clean up a little here. Okay. This is a similarly empty project. There's just an app delegate that doesn't do much, and a little view controller that doesn't do much. So we'll go to the view controller, and we need to add a few instance variables to this. We need to, we're going to be generating all those labels, so we need sort of a temporary rec to manage that with. And then we need pointers to all those labels so that we can cause them to animate their appearance as we receive the appropriate events. And finally, we need that button that we're putting at the bottom that's going to actually be generating all these events. So in the implementation, we'll add a method called addLabel with text that'll just take care of generating one of those labels for us. It'll allocate a label, set an appropriate font, color, text alignment, alpha or transparency, the text that's passed in, and finally add that into our view controller's view, and then clean up. It'll then position it based on where the previous one was positioned so that we sort of stack them down the screen, and then finally return it. Now, when one of those events fires, we sort of want to highlight this so it flashes on the screen, so we'll add a method called highlightLabel. Scroll it so everybody can see it. All this will do is set the labels alpha to 1, so it's fully opaque. And then we're going to begin an animation context. You guys talked about animations and stuff, so this should be old hat to you. Begin an animation context, set the animation duration to 1.5 seconds, set the alpha back to wherever it was, which was the default alpha in this case, and then commit the animation. So that'll cause it to go opaque and then over 1.5 seconds fade back to partially transparent. Now in our view.did.load, we want to go ahead and set an initial label rect, and then we're going to create all those labels and just assign them to the instance variables that we already created. And then we'll create that button that's going to sit at the bottom. We'll set a title on that and then add it into the subview. And then finally, we now need to associate those actions, those events to actions on our view controller. So basically, we'll add ourself as a target with some selector that's appropriate for each of the event types, and then pass in whatever appropriate control event there. So let's see. Now we need to provide implementations for all those things. So we'll look at one sort of in particular. Touchdown we'll simply call highlight label, touchdown label. The rest are all pretty similar. And then finally, we just need to release all of those objects when we're done. And I think that's it. So now if we run this, hey, let's do the same thing. Good. If we run that, we have our control at the bottom. When I press down on it, notice the touchdown highlighted for a second. As I move around, I get a drag inside is staying dark, which means it's receiving a continuous sort of series of those. If I pause for a second, you'll see it fade back out. If I move over and cross the boundary, you'll see there's actually a threshold outside controls that you have to actually cross to get an exit. Because again, touch we're tracking fingers here, right? And people aren't as precise with those. So we give you a margin of error. If you get far enough outside the control, you'll get an exit. And now we notice we're dragging around outside the control. And if you get close enough, we'll come back. We'll get an enter followed by a series of drag insides. And of course, if you lift, you'll get a touch up inside. Or if you drag out here, you'll get a touch up outside. There's no easy way for me to simulate a cancel here. So, and if I tap multiple, you'll see touchdown repeat. I'm tapping there. That sort of shows all of the different events that get generated. Any questions on that? Okay. So there's a couple other sections that I sort of threw in here from our more recent developer conference that were not in the sort of summary. After having used this for a couple of years, we've sort of come up with some best practices and some gotchas and some areas to avoid. So we'll just sort of touch on those briefly. So the view that's returned by that hit test with event method that we talked about really has to handle all the touches. We talked a little bit about the responder chain and how touches, if you don't provide an implementation for these touch handling methods, it'll go up the responder chain looking for some other view. Well, this is potentially bad. If you've got a view that is returned from hit test and it handles touches began, but let's say doesn't handle touches ended, some other view up the responder chain somewhere is going to get a touches ended for a touch that it never saw a touch began for, which may leave that other event or other view in some inconsistent state or even cause a crash. Now, this doesn't mean that whatever class that you provide itself has to provide implementations, but so for example, if you subclass from something that already provides implementations, you may just get away with overriding the ones you care about. But if you subclass from UI view, it doesn't have implementations for these things, and so you need to provide all 4 of them. So there's the set again that you need to provide. So what does this mean if you're subclassing UI view directly? UI view, like I said, doesn't provide implementations for these. It inherits UI responder's default implementation, which goes up the responder chain trying to find some view that can handle them. So what happens if I have a custom view that's a subclass of UI view and I throw it inside a table view, and let's say all I care about is the touches ended because I'm looking for tap count or something. The touches began and moved will go up the responder chain. The table view will see those. But when the end comes, it'll be delivered to your view because you've provided an implementation for that. And the table view will never see it. So the table view will think there's some touch that's still on the screen that just isn't. And you'll leave the table view in some inconsistent state. So the rule here basically is if you subclass UI view, you have to implement all of the touch processing methods. And you cannot call super because calling super goes to the UI responder's implementation and goes up the responder chain. And you'll end up with multiple views trying to process that same touch. But let's compare that to another UIKit class like button. Button actually already handles all the touch methods. If you subclass button, you don't actually need to provide implementations for all of these because the view itself actually provides implementations. It's not going to go up the responder chain. So you're free to override one or all of these methods, but the rule is you have to call super in that case. Because if you don't, the button won't see a full event stream. For example, again, if you override the end and don't call it, the button will see the began and moved, won't see the end, and it'll end up in a bad state. So the rule there is if it already provides all those implementations, you can override just one, but you have to call super. Touch forwarding is another tricky area. We found a lot of cases where people were doing things like putting a big semi-transparent view sort of over everything on the screen, catching touches, and then sort of rerouting them where they thought made sense at the time. There's nothing actually inherently wrong with touch forwarding, but there are some rules about when you can use it. Say, for example, you have a big view here, and that big view is going to catch all of the touches. But under certain circumstances, it's going to forward them to views A, B, and C, whether it's in there or not. if you do that, every single one of those views that's involved in this needs to be views that you own. They actually need specifically to be subclasses of UI view, not other UIKit controls. Like you can't subclass button and throw one of those in there. It does not know how to process touches that aren't bound to it. So sort of a special case, hopefully not something you guys will need to know now, but definitely if you find yourself thinking you need to start forwarding touches to other views, stop and think about what you're doing for a second, because that path is rife with error. All right, so there's a few little gotchas. This is a big one we saw really early on. People handling touches began, moved, and ended, but not canceled. And most of the time, you don't get touches canceled. And so in all your testing, everything seems to work great. And then the one user who's using your app, when a phone call comes in, leaves your app in some inconsistent state, and it's erratic or crashes. So whenever you handle any touch methods, be sure you handle cancel and think about whatever is appropriate for your application when a touch is canceled. I mentioned this a little bit before, but forwarding touches to UIKit classes is simply not supported. All of the UIKit classes that handle touches, from buttons and table views and things like that, can only deal with touches that are bound to them. So if touch.view equals the table view, then it's going to receive those touches. If touch.view doesn't equal the table view and it sees one of those touches, we cannot guarantee what will happen. It's not designed to handle that. So again, avoid forwarding touches to UIKit classes. Similar to what I mentioned before, if you subclass a UIKit class and conditionally call super, this is exactly the same case as just not calling super at all. Basically, the parent class doesn't see the full event stream, and you're going to leave that view in some inconsistent state. So if you subclass a UIKit class that provides implementations, you need to let it see the full event stream. Yep.
What if you just don't ever call super on any of them and you implement them all? So you can like subclass the UI button and implement all the things yourself.
That's totally fine to do. Actually, in that particular case, I'm sorry. If you subclass UI button, override all of the methods, but don't call super on any of them. You won't get any of the default UI buttons event handling, but that may be fine for what you're doing. But that actually is an okay sort of edge case. But only because the button isn't seeing some partial event stream. That's really what you're trying to avoid, is something like a button seeing a partial event stream, or seeing something that's associated with it, something like that. So we see this a few times where somebody's trying to do something kind of tricky, like, for example, they're handling a touch, and in the touch is moved, they want to stop processes. They call they call super touches ended from their touches moved. That's who knows what state that's going to leave the parent object in. Basically, it's been told a touch ended whose phase was moved, so it wasn't even in the correct phase. But then you haven't really told the touch handling system that touch is ended, so it's going to continue generating events for that thing, and the view may see more of those. And basically, if you're calling super, make sure you're calling super for the actual event handler that you are overriding. So that's really it. That's everything we discussed today. We have a little bit of time for questions, I guess. If no questions, oh, we got a couple.
What's the maximum number of touches it can handle at once?
So the iPhone, I'm sorry. What is the maximum number of touches that can be handled at any one time? The iPhone has a limit in current shipping operating systems of 5 touches. I don't know if we can talk about anything going forward at all. Okay, so the limit currently is 5. So there's another one back here.
I was just curious, how are you making that code appear?
How is it making the code appear? Oh, So one of the guys that works in our developer technical support group has a little app called Demo Monkey, which basically VIN's a service. You know, you've seen the services menu in the Mac where one app can provide a service to another. And it just VIN's a text service that when you hit a hotkey, it takes whatever is currently in the pasteboard, pastes it in, and then takes the next thing in a script and puts it in the pasteboard. So it's, yeah. You know, some over here? Yep. What about iPad? So how many touches can you have on the iPad? You're nodding your head? Right. Okay. No, it wasn't talked about publicly, so I can't say. It's a bigger device. You might imagine 5 isn't enough. Like.
For more, please visit us at stanford.edu.